Duncan, who's a co-organiser of these talks. We also have Nick Ribbons from Zero Waste Scotland, and Zero Waste Scotland is supporting this project. I'm just going to hand over to Nick right now just to give a quick brief about information about Zero Waste Scotland for those who don't know what it is.
Thanks, Rachel. Yeah, and thanks everyone for joining us. We're really proud to be a part of this and working with Rachel and Becca to deliver a series of these talks, and really delighted to have Eustacia as well. Zero Waste Scotland are an organisation which have been independent since 2014, but we've been around for a bit longer than that. And we are Scotland's resource efficiency and circular economy experts. And our agenda really is to sort of accelerate Scotland towards a circular economy. And we work with all sectors and we work with individuals and local authorities as well, and clients too. And my specialty is the area of the built environment. So obviously this falls into that, and it's something that we're really keenly interested in, and even more so around looking at embodied carbon and how we begin to tackle it as it sort of gains increasing prominence. And obviously with the stringent carbon targets we have, we need to begin to understand what they mean and how we can sort of meaningfully work towards them. So I won't take up any more of your time, but thank you so much for joining, and I'll hand back to Rachel.
Okay, just a couple of small admin bits. If everyone can be on mute when if everyone's on mute, that would be really handy, so we don't get any back chat. Also, as we said, we're recording the event and we will be sending it out to you and also putting it online, so the information can be shared among as many people as possible. During the talk, if you have any questions, pop them in the chat box and we'll address them at the end. It'd be really helpful if you could put, if you've got a question, you put the letter Q before you actually type your question. The same as if you're answering someone, just put an A and then put your answer, or if you're putting a comment, letter C, just because it'll make it easier for us scanning through the questions at the end, so we can hopefully address everyone's questions. So that's all the admin over. I'd first like to welcome to the first of our series, looking at sustainable design solutions for the landscape industry in response to the climate crisis. By sustainable, I mean understanding how to meet the needs of the present without compromising the needs of the future generations, and at the same time protecting the environment. As I'm sure you're aware, we need to strive towards this fast for the health of our planet, as well as every organism living on it. We're in a good position as designers and landscape contractors to create gardens and landscapes that are good for the planet and good for those inhabiting it. It just requires some forethought and changes to how we're designing, specifying and building. It's fantastic this subject is increasingly being talked about in the industry. There's been much focus on the we need to do, but not the how. And a couple of years ago, Becca and I started talking about what it is we need as designers to create gardens that would have a low environmental impact. We realised we need the information on the how. So this short series of talks is to provide some knowledge on the how on a range of subjects. That is to start to fill the gaps. So that's enough about all that. Today, we're going to hear about the Climate Positive Design Challenge and to see a demonstration of the Landscape Carbon Calculator Pathfinder from Eustacia Brossart. Eustacia worked alongside Pamela Conrad and Atelier 10 to develop both the challenge and the important carbon calculator tool. Eustacia is an award-winning master landscape architect working with CMG Landscapes in San Francisco. So she's joining us all the way from across the pond tonight, or her morning. She is passionate about the urban landscape's potential to sequester carbon while creating dynamic, resilient, inclusive places for people, ecology and art. So without further ado, I'm going to hand you over to Eustacia, who you really called in to hear, not me. So thank you, Eustacia, over to you.
Thank you, Rachel. Thanks everyone for joining. Good evening. I know it's quite a lot to ask to spend another hour staring at your screens these days, so I really appreciate you being here. As Rachel said, my name is Eustacia Brossart, and I'm a landscape architect at a firm called CMG Landscape Architecture in San Francisco. Talking to you from my living room here in San Francisco. And so my plan is to give you a little presentation and talk to you about the climate positive design challenge and this effort that we've been doing here. And then we'll take a look at the website and this Pathfinder tool so that you guys can hit the ground running if you would like to use it for your own projects. So, share my screen. And all right, can everyone see my screen? No, I can't see you, so.
No, we can't see your screen.
Oh, no? Huh. Okay. How about now?
Yes.
Okay, great. All right. So climate positive design going beyond neutral. Here in the American West, we've been having some pretty acute impacts of climate change lately. This was a shot looking east where the sun should have been earlier this fall from my living room, and it never came up that day because it's been so smoky, the Sierra Mountains. So like many Californians, I'm starting to wonder whether I might actually have to become a climate migrant quite soon, far sooner than I would have imagined. Places with lots of, water and fewer fires might be getting an influx of Californians, so you guys should watch out. But we've also seen in the past year during quarantine the effect that human actions can actually have on the air and wildlife and the water, which have rebounded a bit. So this is an image from Delhi, and the image on the left is the air quality in November 2019 versus at the end of March 2020. So we can have an impact, and we don't have to wait for policy changes or permission from the government, which has been difficult here. Hopefully we'll start to turn that around. But what we wanted to do as landscape architects was figure out what impact we could have in our work. So this is CMG Landscape Architecture back in our office, and we are a mission-driven landscape architecture studio. Our mission is to increase social and ecological well-being through artful design. So a lot of the work that we've done has been related to climate adaptation. So for example, this is a man-made island in San Francisco Bay that we've been redeveloping, which is quite ambitious goals and construction practices in relation to sea level rise. And we've also been working with the San Francisco port to create a resilient waterfront all across the city of San Francisco, again, to help adapt to sea level rise. And it's important for landscape architects to help our cities and towns adapt to the effects of climate change, but we wondered whether we could help mitigate the causes of climate change as well to get to the root of the problem. And as Rachel mentioned, and we all know, we need to make massive changes very soon, right? So we'll need to adapt as well, but we should be trying to improve the situation at the root cause first or concurrently. So as we know, the urban and suburban built environment is a huge contributor of greenhouse gas emissions. But our question was, can we change that story and reduce greenhouse gas emissions and sequester as much carbon as possible through our urban and suburban and rural landscapes? Yes, is the conclusion that we came to. So as landscape architects, as garden designers, we're uniquely positioned within the building design fields to actually sequester carbon through the trees and plants that we install, which intake carbon dioxide and store it in their wood and in the soil. So my colleague, Pamela Conrad, whom Rachel mentioned, had a simple question, which was, how can we minimize the emissions and maximize the carbon sequestration of our projects? But we looked around and realized that there weren't actually tools, resources, and guidance available to help us figure out what our carbon impact is. So we started to develop our own tools. We used data from an architecture Athena database for embodied carbon in materials. Nick mentioned, you know, the shift toward looking more at embodied carbon, which is relatively recent in the building fields and didn't really exist in landscape architecture. So that's what we're trying to do here. So figure out the embodied carbon in the materials, and then we used US Department of Agriculture forestry data to get tree carbon sequestration data. And using those, we started to look at some of our own projects, and we were pretty surprised by what we found. I think probably you guys as garden designers like myself assume that our landscapes are generally a positive force in the world, right? We're bringing greenery, et cetera. But what we found at some of our own projects, and bear in mind, my firm's about 40 people, and we tend to do sort of larger projects. So it's a slightly different scale than you may be dealing with. But at this park project, for example, by our calculations, it would take 15 years for the installed trees and shrubs to sequester enough carbon to offset the emissions of the materials, as well as the construction and the operations of the park. But we figured out that with some minor design tweaks, we could dramatically change that carbon story. So how do we do this? First, we need to reduce the quantity of carbon that we're emitting. So the biggest way to do that is just to reduce the quantity of paving, and then to use materials that have less embodied carbon in them. So for example, here, if we were to use decomposed granite instead of concrete, we cut down on carbon dioxide emissions quite a bit. And then we'd specify electric and organic maintenance practices to reduce the ongoing emissions of carbon. And we reduce the quantity of turf. Turf, especially manicured turf lawns, are actually a carbon emitter due to the maintenance over time. So with all of those changes, we could cut the carbon emissions of this park in half. And then, oops, skipped ahead too fast. And then by increasing the quantity of trees and shrubs, especially in those areas where we've reduced paving and reduced lawn, we could then increase the carbon sequestered during the project's 50-year lifespan by 50%. And so that cuts our time to carbon neutral down to 5 years. Here's another project that we looked at. This is a plaza project, and these tend to have much higher carbon emissions since due to the quantity of paving and the fairly sparse planting in plazas. So this one, for example, would take almost 200 years to reach carbon neutral. But again, so in this situation, we still need a lot of paving, but by switching to concrete that uses cement substitutions, and by converting some of that concrete to decomposed granite and increasing the quantity of trees and shrubs, we can cut the emissions by 2/3, more than triple the sequestration, and reach climate positive in 20 years. And you can see that we haven't really changed the design intent. It's just frankly more green and pleasant. So based on these case studies that we did in our office, we set the Climate Positive Design Challenge, which we launched during the Global Climate Action Week back in fall of 2019. And the challenge is for landscape architects and designers around the world to shift how we are designing our landscapes. So the targets that we set are that parks, gardens, campuses, residential, and hospitality landscapes reach climate positive, meaning reach neutral and then begin sequestering more carbon than they have emitted within 5 years of construction. And for plazas and streetscapes, the target is 20 years to climate positive. And again, that's because of the inherent quantity of paving needed for those types of landscapes. So as you can see here on the left, if we continue, by our calculations, if we continue practicing landscape design as we have been, our projects will actually continue to emit more carbon than we sequester in the next 30 years. But if we were to shift and meet these climate positive design targets on all projects worldwide, and this is, you know, sort of a napkin calculation, by 2030, we think that we can sequester more carbon than our projects emit, and by 2050, we could remove 1 gigaton of carbon dioxide from the atmosphere. And since our profession is relatively small, that would be pretty powerful effect. So these are some of the many folks who have contributed to climate positive design, including our latest version of the Pathfinder tool, which is much improved, is designed by one of your countrymen. And some of the organizations that have been contributing to and advising on this challenge. So I'm gonna stop the presentation now, and we will take a spin through the website, which is climatepositivedesign.com. Give me, all right. So, are you still able to see my screen? Are you still seeing my screen or just my face? Still seeing my screen. Great. Yep. Okay. Okay, so climatepositivedesign.com. All right, so first, let's take a look at the resources. So here we have the case studies that we looked at. These are, I showed you a couple of these, and there's a few more in here. Garden, kind of community garden project, some campuses and additional parks. And we also have in the resources tab, the data report, where you can learn about all the metrics that were used, some of the additional research that needs to occur. And, you know, we're landscape architects trying to do all this. We're not experts in either technology or carbon sequestration. So this is all sort of a beta version, and there's certainly a lot more information that we need, more research is needed, and we welcome all comments on this connect button here, or connect page. You can contact us with any suggestions, if you find any problems with the app, if you, you know, suggested areas of research. And okay, also in resources, we have a number of other links that you can check out, as well as the design toolkit, which you can download as a PDF. And here we've listed by different categories, for example, materials that have lower embodied carbon that you might use for pathways or for walls and fences and furnishings, for example, rather than building a concrete or steel trees. And according to the data that people have entered, almost 800,000 trees planned for planting. In this map, you can see where people are contributing projects from. So there's quite a number in Britain. And at the moment, we are listing everybody who enters a project is listed as a contributor to the challenge, if you agree to that. So quite a number. Through that. So let's use the Pathfinder. So the Pathfinder is the name of the kind of application, meaning the tool that you can use here to calculate the carbon footprint of your projects. And the basic premise is, okay, how much carbon am I emitting and how much am I sequestering? So, you know, the more carbon that your project emits initially, the more that you would need to plant in order to sequester carbon to bring down the number of years to carbon neutral. Now, ideally, we're emitting as little carbon as possible and sequestering as much as possible, right? So the first step is that you draw a site boundary. So I'm going to redesign the Arc de Triomphe in Paris. This, I don't know if it's concrete or stone paving area here. So the first step is you draw your site boundary. Okay. And it tells you, in this, it's listing it in Imperial at the moment, 1.5 acres, okay. And now if you have a more specific project area that you know, or if you want to switch to meters, you can plug that in here and continue. Okay, and then here you plug in the title of your project, what type it is. So in this case, let's say we're going to turn it into a park. When you believe it will be completed, and that determines you know, when it will hit neutral. The units that you want to use, so we'll use metric here, and I'll try and do the conversions in my head. And let's say we are in concept design. And this is very important when you're just trying out the website. Please check this little box here that says, is this an academic study or project not expected to be built? That way we're not counting the data from whatever you plug in if you're just trying things out and messing around. So we're going to say this is a design alternative. This is demo number 1. Okay. I'm actually going to go back here. Whoops. Back. Okay. So these, this image, you can change here. It's being a little wonky, but you can drop in an image here that represents your project. I don't know why this living room popped up. And here you can, that's your completion date. You can change it there. The units that you're using. This tells you what units you'll be using for small units. Then here's your area. You can change that if needed, and the phase. Okay, so we're calling this our primary design at the moment. You can have multiple versions of a project in order to test out different ratios, different materials, but only one can be the primary design, and that's the one that will be counted. So we'll say add detail. And the first thing that we look at is the materials. So we're going to look at our embodied carbon. So here on the left, you can either search for a material or you can search by category. So let's say paving. There we go. Okay, so these are listed in order from the least embodied carbon to the most. So I'm going to say that we're going to have a few pedestrian concrete paths running across the circle, the plaza. And I know that it's about 40 meters across. So let's say we're going to have 3 paths, so 120 meters, maybe 3 meters wide, and 150 millimeters deep. So now if you can see this red number here, this is telling you what the embodied carbon is in that quantity of concrete. So let's now add let's have some decomposed granite paths as well, which is listed here as stabilized crushed stone. We're assuming that it's stabilized with some kind of glue. We'll do the same, maybe another 3 paths, same, oops, same size, except these will be a little thinner. Oops, oh, okay, there, as Rachel found out in working through this, there are some glitches. So for example, here, this is listing this as meters. It's not gonna be 100 meters tall. Thick, it's gonna be, there we go. Okay, so you can see here that in the same area of pedestrian concrete versus decomposed granite, the pedestrian concrete is a far higher, what was that, about 20 times higher carbon footprint, emitted carbon than decomposed granite. So now in these, you can also switch dimensions. So if, let's say that instead of knowing the length and width, you know that it's, what is 360 cubic meters, excuse me, square meters, 150 millimeters. Or if you are perhaps a contractor, or if you have a full cost estimate and you might know the volume in cubic meters of concrete, you can input that here instead. So you hit these switch dimensions, this button up at the top, in order to do that. And there is additional information under this little book. It tells you this is a climate negative element, meaning that it's emitting carbon, not sequestering. Tells you what the emissions are at the source per cubic meter. And it tells you over the lifespan of the project, we expect you to have to replace this once. And we're using 50 years as the lifespan of these projects. So that's factored into this quantity of carbon, is the expectation that you'll have to replace that concrete once. Whereas the decomposed granite, we expect you're gonna have to replace that twice. There's also notes here that sub-base materials are not included. So to be thorough, I now need to say, okay, well, we're also going to have probably some aggregate base underneath these pathways. So 6,720. Oh, I'm going to go with area, and we're going to say it's 720 square meters and maybe 100 millimeters thick. Okay. So now we have kind of the the impact of the paving. And in the corner here, it's not yet listing years to positive because we have to input the number of trees and shrubs first. But before we do that, let's say we're going to have maybe a concrete site wall as well. Let's say we're going to run that down all those concrete paths, and it'll be, this is a seat wall, so 0.5 meter wide, and let's say down to the footing, it's going to be about 1 meter deep. Now down here in the green, it says, it pops up briefly saying that this doesn't include the foundation or the rebar. So I'm going to add the concrete foundation, which I will switch dimensions. I'm going to assume it's also 120 feet long, but it's probably 1 meter wide, and let's say 200 millimeters thick. And we need the steel reinforcement as well, which I will say is 120 square meters. Okay, so now we have our walls. There's also fences and gates, which, as Rachel found when she worked through this, it's you have to kind of make some calculations in order to do this, but you would list how long it is and the width of the actual boards. So, you know, probably, I don't know, 0.1 meters, let's say it's 0.1. And the height of the fence. And you can see that wood has a pretty low impact. It's considered to be close to carbon neutral because the carbon that's stored in that wood as the tree intakes it is then retained in the wood when you use it as a fence or as furnishings. Steel, on the other hand, even though it's much thinner, so let's say 0.02 meters thick, 2,000 meters tall, has a much higher impact. There's much more carbon emitted in the process of making steel. So you can also, you can add in different trellises, decks, and then at the bottom here, it says, can't find what you're looking for, create a custom material. So you could select your category here, and if you know the kilograms of carbon dioxide equivalent per unit, then you can enter that here and create your own element. And let me pull that up. We call those, I don't know if they use a different term. Oops, pardon me. We call them environmental product declarations. So you can, if you are using a product from a manufacturer, a bench or something, a light, you can ask them for an environmental product declaration, and that will include this information. This one is an example from a concrete manufacturer here. It tells you the global warming potential of that product, and they're supposed to take into account where it comes from, how it's, you know, how it's harvested or manufactured, et cetera. And that's measured in kilograms of carbon dioxide equivalent. So then that's the information that you would be inputting is from that environmental product declaration. which, yeah, this one is from Norway, also called Environmental Product Declaration. So I think that's a relatively worldwide term. So you can create a custom material that way if you're able to get that data. And the more that we ask manufacturers to provide that information and let them know that this is something that we care about, the more that we can start to move the industry in a direction of trying to minimize the embodied carbon in materials. So once you have all your materials that you're building with, then we start to input our plants. So let's start with trees. And first you say, so they're just organized. We're not at the granular level of by species. These are based on whether it's evergreen or deciduous and the size. And this is, again, this is based on US Department of Agriculture, Forestry information about tree sequestration. So let's say we're gonna put in some large evergreen trees. Now, the first thing you've got to do is select the zone that you're in. I believe, I'm positive, I think, yeah, I believe Paris is in the central zone worldwide, and this impacts how much trees sequester based on light and climatic conditions. So let's say we're going to put in 20 evergreen large trees, and maybe another 20 deciduous large trees. You can see that deciduous trees, large trees actually sequester more, a little bit more than evergreen. But you can also see now down here in the corner that based on what we've input so far, even with 40 trees packed into the Arc de Triomphe Plaza, it would take 66 years to hit carbon neutral. So that's not so great. So let's look at shrubs. And here we have, no, oh, okay. Let's say we're going to have, I don't know, 200 small deciduous shrubs and another maybe 500 larger deciduous shrubs. Okay, so now we're down to 44 years to positive. If we were to add lawn, there are four levels of management. So if we were to use intensive management lawn, I'm going to switch to area here. Let's say 2,000 square meters. You can see that this is actually emitting almost 20,000 kilograms of carbon dioxide because of the maintenance over time. So if we were to, I'm going to delete that element, so we don't want that. If we were instead to use moderate management lawn, that would be less, a no-mow lawn, or which is the closest we have currently in the calculator to like a meadow. Would have much lower impact and in fact will actually sequester some carbon. So now we're down to 29 years to positive, which is a lot better, but let's see if we can't do a little better than that. First though, we need to look at our operations. So this is where you can plug in what's the construction of the project as well as the ongoing operations. So for example, let's say we're going to demolish all that paving, which I think I'd said it was 66,000. square meters, and let's say 150, no, 0.15. Okay, so that's quite, there's quite a lot of carbon emitted in the process of the demolition. And then you can also enter information here about what kind of fertilizers are going to be used, as well as information about whether whether there'll be leaf blowers, etc. You kind of need to know a lot about these in order to get this information in. I wish it were a little bit more user-friendly, but that's the data we have at the moment. What else? You can you can choose here whether you're using no-till approach or whether you're doing quite a lot of grading, in which case you would enter the area that you're grading and which is calculating up here what the impact of that is. Looks like it's taking a little bit of time. You can also list here what's happening with existing trees. This isn't, the existing trees at the moment aren't quite capturing everything that I would like them to. You can choose, sorry, this is still calculating. Maybe I'm gonna take out this. Okay, well, so you can list whether with the existing trees, if you're cutting any of them down, are you turning them into mulch? In which case most of the carbon is re-emitted fairly quickly. Or are you turning it into furnishings, in which case, as I mentioned before, as with fences, most of the carbon will remain in that wood, so it's effectively, you know, locked in and kept. Or if you're turning it into biochar, which is, if you're unfamiliar, is a way of heating up the wood or other biomass in order to kind of lock the carbon in, and then can be used as a fertilizer that has great potential to sequester carbon for a long period of time, as well as improve fertility and nutrient uptake in the soil. So, okay, now we're at 94 years to positive, so that's not so great. So let's go back and see if we can't reduce that somewhat. I'm going to take out this pedestrian concrete. And if that can happen. Sorry for the delay here. Okay, well, in case this is going to be too pokey to actually function, what you would want to do here, if this were your project, is kind of toggle these and see, okay, well, if I switched that pedestrian concrete paths, if I switched those to decomposed granite, or if I switched those to a wood deck, or to gravel, what would that impact be? And of course, that would dramatically cut down on the quantity of carbon that's emitted. By the same token, if instead of using concrete seat walls, you were able to use wooden seating elements, or if instead of using a retaining wall that's made of concrete or steel, if you're able to use rammed earth, you can dramatically cut down the quantity of carbon that you're emitting. And then, of course, by then increasing the quantity of trees and shrubs, quantity of meadow as opposed to turf, you can increase the amount of sequestration so that hopefully you're hitting carbon neutral within 5 years if it's a residential project. That's our target, or 20 years for a plaza or a streetscape. So let me see if we can look at the scorecard. No, okay. Well, if I hadn't given this too much information too early in the morning on my side of the world, you can here click on View Scorecard, and you'll get a neat little graphic showing what. Let's see. Actually, why don't I pull up an example of one from another project? Let's see. Okay, so here's one with only 1 year to positive. That's quite good. So what you see here is, well, let's do one that's a little bit more normal. Okay, so on the left here in the red, that's the amount that's emitted initially, right? About 200 metric tons of carbon emitted initially, and then the trees and the shrubs and perennials are doing their sequestering work, and you hit neutral, in this case around 2043, and then beyond that would sequester about 250 metric tons by 2070, which is 50 years out. In this graph, you can see what are the major sources of the carbon that is emitted. So paving is the biggest one in this case, walls, lawn, the drainage, etc. And then there's more data on the next page. So if you enter your project, you can click on that View Scorecard, and you can download this. You can show it to a client. And we've found this to be a very helpful tool in getting clients to agree to have maybe 1 or 2 more trees than they would have otherwise wanted, or to switch from having concrete to having, maybe some recycled material or a gravel path instead. And of course, that's what, the basic tenets, I think we all know, but the power of this tool is in having the data to be able to show your client the impact that different choices can make, and to get people excited about how much they could sequester in their own yard or in a park over time, and that we are each individually contributing, right? It feels a lot better than the sort of constant doom and gloom. So I'm going to stop there because I've nearly run out of time, and let's see what questions we have. I'll stop sharing.
Great, that's great. Thank you, Eustacia. We do have a few questions. I think some of them I think you may have answered as we've gone through, but sometimes it's worth just covering them again to make sure everyone's fully, because it's a tool, it's something people need to be able to use. So one of the questions, I just wanted to know, you talked about recycled products then. Do you often find you can get the environmental product data for recycled products?
It entirely depends on the manufacturer. It's harder actually if it's recycled, right? If it's in the best of all worlds, you'd use the materials on that site and reuse them in a creative way. That's going to be your lowest carbon impact. In the current state, it's a little bit harder to input that data into the tool. But again, we're very, very much would like your suggestions and questions, and we're trying to do more research and get more data in here in our spare time. So bear with us, but yeah, hit that contact us link for any suggestions like that.
That's great, thank you. Right, just running through the questions here. Hopefully I'll get them right in terms of context, how people were describing them. The first question we had from Jelaine was, if carbon is sequestered and stored in the soil, are we just shifting the problem from air to soil?
It's not it's not a problem, because as far as I understand, the natural carbon cycle is that the carbon moves from the atmosphere into the soil through plants. And so I believe soil, contains something like 80% of the carbon in the world. Don't quote me on that. But that is the natural cycle, right? So that's an interesting question. If we were to afforest the entire planet and start sequestering a lot more carbon in the soil, would that be a problem? I don't think so, because it's carbon in the soil is what all life comes from, right? But interesting question.
Yeah. I guess also in context of when that question appeared in this talk, I think also if in the built environment, if we're reducing the amount we're emitting in our garden, in the gardens we're building, or the parks or landscapes we're building, and increasing sequestration, once you've gone to the neutral, then you've got your it's being carbon positive in terms of it's also taking up extra carbon from other sources, not just the build of the landscape as well.
Exactly, and that's our goal, is that as landscape architects, we're not just treating our own, offsetting our own emissions, but that we're actually pulling carbon out of the atmosphere, because that's what we can do. That's our contribution.
Yeah. Decomposed granite, you've mentioned it a few times, and I think you answered the question. It's like resin bound gravel, that kind of, is that what yeah.
That's what we call it, right? When it's crushed stone and then it's resin bound, yes.
Yeah, okay. Susan, you asked a question about persuading new clients to take on these sort of lower environmental impact options. Did the end of the talk answer your question in terms of how we can take those scorecards and show clients the options?
Yes, I think it did, but I think it would also be helpful if we were able to estimate what the carbon factor is in their existing gardens.
Yes, so you can do an existing conditions version. It doesn't have as much information as we currently have for construction, but try that out and let us know if it's not satisfactory.
Yeah, it could be assumed and then shared with the client as being assumed. And that would then enable us to really sell the potential for a greener garden.
Right. I mean, the reality is that, as I mentioned with the carbon cost of demolition, a lot of times it would be better to do nothing than to build, right? But if you're taking out pavement and putting in more plants, then over the long term, that will be better.
We will no doubt get inquiries from prospective clients who would like to do something in their gardens. So I think the answer is trees.
Trees and shrubs, yeah.
And ground cover plants, I feel, have quite an important role to play too.
Yeah, we've found that shrubs can have quite a role.
Thank you.
Thank you. I think a few people have referred to asking about where, I think it's the carbon equivalent information that we've got there. It takes into account, if I understand rightly, where it's manufactured, how it's manufactured, where it's coming from. So I think I'm probably going to answer, but you please feel free to chip in. That if you've got the environmental product data specific for a particular product you are interested in, then that will take into account the different locations. The information in the carbon calculator, is that from America?
Yeah, and what we've done, because of course becomes quite complicated. So we have we have this kind of basic carbon equivalents that are provided from the architectural database. I am not positive where it's assuming those products are coming from, but we've added in a contingency that just kind of takes into account transportation without getting into the fine grain. So it's not quite at the level of sophistication of, you know, which quarry is it coming from. But if you're able to get that information for the specific products that you're using, then you can add those specific elements, as I showed, that would have that information. The other thing that we would like is to start having, you know, as always in these situations, we're trying to figure out sources of funding as well to keep this going. So we're hoping to have more manufacturers list their, if there are manufacturers who are creating low carbon products, we're hoping that they will want to list their products on the website. So if you know of any or are working with anybody who might be interested in that, please let us know.
That'd be great, thank you. But on a, I guess on a higher level, if you want to just use the, if we can use the tool though to and use those more generic figures, it gives us a relative
right.
Yeah, gives us relative figures to work with in terms of how we can change our design and have a negative or positive impact on the environment, which is at least the first step. It's better than what we currently have, so
right.
It's not a bad thing. I think the only other question, I think there was just question about the carbon footprint of tools and machinery, and is that included in the which bit was it called, the operations section?
It's, yeah, so with every we have a kind of construction contingency built in to the materials.
Okay,
so that's factored in.
Okay. I've just a quick question on something you mentioned very early on, was about the tiny forest. And planting very quick, fast-growing trees. I just wondered what would be the plan for at the end of their life, and what would intend to happen with those trees, and whether you'd end up then replacing them.
Probably. I mean, as I mentioned, the best ways to deal with trees at the end of life in order to maintain the carbon in them is not to chip them up, but to either turn them into biochar or turn them into furnishings of some kind. Or, you know, nowadays there's the mass timber movement within architecture, an attempt to use sort of glue laminated wood to build taller buildings in order to get us away from concrete and steel. So hopefully in the long term, we could be moving more toward that kind of cyclical work.
That's interesting. Also, just picking up on the biochar, do you have like commercial entities where you could send your wood to be turned into biochar, or have someone come to site and turn it into biochar in the States?
Yeah, there is at least one large producer of biochar near here. In the San Francisco Bay Area. You know, it's a relatively nascent industry, but they do exist. I know a lot of people are excited about it. Yeah,
I've just been listening to a podcast about biochar. I was aware of it, but not as a growing medium, but I hadn't really appreciated its potential. So that's really useful. Is there any other questions? I'm just checking here that we haven't missed, because some extras might have come in. Oh, someone mentioned, where do the landscaping maintenance emissions show up in the scorecard? Are they actually shown on there as well, if you have?
I believe it is. It's a great question. It's shown in the second page that lists all the impacts from the materials, plants, and operations. And on the first page as well, it's listed, yes. And that it's factored into the graph that shows the how much carbon is emitted.
Okay. Hopefully that answered your question, Jane. And I guess as a general sort of comment is,
yes, the Pathfinder tool is free. Sorry, I'm just looking at questions.
Yeah, no, there's a comment about the.
Tell your friends.
Yeah, from Bose, are we to be super accurate, or if we just use this as a broad brush idea? So I appreciate if we're trying to register our projects to be counted in the challenge, then yes, we need to be accurate. But I guess if we want to use it as a tool to help us improve our designs, then we could use it as a broad brush and maybe just tick the academic box. Would that be okay?
Yeah, absolutely. And I understand that there's that tension between wanting to have precise data and wanting to have something you can do quickly, right? Or maybe you're at an earlier stage of the design and you don't have as much information. You don't want to plug in all the rebar that's being used and everything. Yeah, I think as Rachel mentioned, thinking of this as a relative tool to say, here's the kind of status quo if we were to do this all in, big concrete patio and one tree. What if we made some changes? Here's what it might be. And yeah, and is it going to be exactly that number of kilograms of CO2? Maybe not, but as a relative tool to inform, I think it's useful. Yeah. And then sure, just mark it as a. If you're planning to build it, you can go ahead and mark it as a real project. Mm-hmm. But if you're still designing, you can mark it as an academic study.
That's great. Well, thank you very much. Hopefully, one further question came in here. Do you provide quick numbers to give clients an idea of trade-offs?
Yeah, we've been trying to incorporate this into our projects at early phases of design to give clients an idea of that and think about, in that situation, I find it useful to say, okay, this is 1 hectare. I'm going to have 50% of it is going to be concrete and 50% is going to be lawn or something like that, and just use simple numbers and then change those percentages, then that can provide you with sort of quicker numbers.
And I think one more, if you've got a minute, is, and it's quite an important one, is about calculating the footprint of water features and ponds.
Yes, we don't really have water factored into this, unfortunately. It gets incredibly complicated in terms of where it's coming from. Water in California, for example, is much more expensive and carbon intensive than in Britain. So we don't yet have that.
But I guess in general for a pond, or if you're doing a pond that's more formal and you've got concrete base, that's your concrete construction right there, and the digging up the soil, you can break it down that way.
Right. And then the pump, you could plug that in.
Yeah, so I guess you just break it down like anything, wouldn't you, really? And in terms of its water, I guess you're going to have some plants, you could have plants in there that could do something. There's the environmental bit, good bit for the wildlife. So maybe just broad brush the water feature bit.
Yeah, that's a good point. Everything can kind of be broken down to its elements, and that's how we created this this calculator. So yeah, you can kind of figure out a workaround.
And Rose says here, apparently ponds are a major ways to sequester carbon. So that'd be interesting to have a look at.
Interesting.
That. Yeah.
Huh.
Okay,
especially
I think
if they're vegetated.
That's great. I think we're probably over 7:30, and we've still got quite a lot of people still online, which is quite impressive. So thank you so much for everyone attending, and thank you also very much to Eustacia for demonstrating the tool. I said that this is recorded. We'll be sending the recording out so you can go back through the how to use the Pathfinder tool to remind yourself if you need to. And I'll try and summarize some of the answers to the questions that people had, because you might come back to it, and as you're using the tool, go, oh, what was that? And that might remind you.